Hey everybody, Mr. Zamora here. It's a little bit past midnight by the time I'm recording this video, so clearly I do not have a life outside of mathematics. But besides that point, we are going to be talking about, in this video, definite integrals. Now, a definite integral, I wrote a little definition here, that is an integral with specific upper and lower limits. That is the best way to summarize it. So if you watched the video last time where I told you about the introduction to integration, I was only going over examples that didn't have limits to them, like x, dx, or whatever. And if you remember from the last video, if you apply that concept, you actually get 1/2 x squared plus c. Now, if you're curious as to how I actually got that really quickly without any explanation, feel free to watch my last video, because in this one we're actually going to be talking about limits that have these bounds and they have upper and lower limits. So that's a basic definition of a definite integral. Now down here I drew actually a little graph here. Now this is the area that we're going to integrate. As you can see, it's from the lower limit of a, and this is the upper limit of b. And let's say that this is y equals f of x right here. If we were asked to integrate this on an exam, this is kind of the equation that we would use in this case. So here's like the little formula that we have down here. It is an integral with upper limit b and the lower limit of a of f of x dx is equal to f of b minus f of a. Now you'll notice that this is actually a lowercase f, but once you integrate it, it becomes a capital F. Why? I actually do not know. That is just how the equation rolls. That is how the cookie crumbles, I guess you can say. So this is the basic equation that we have right here. So with that out of the way, let's do a few examples. I have about 3 of them that we are going to do here. So here we go. So it's asking us to evaluate this integral from the upper limit of 2 and the lower limit of 0 here, and we are given 2x times dx. Now let's apply the exact same formula that we had last time. So 1 over n plus 1, and then we're going to multiply that by x raised to the n plus 1, and then plus c here. Now the only, let me actually fix that. Now the only difference between a indefinite and a definite integral is that when you are integrating a definite integral, you are not actually going to have a constant right here, since it's actually going to give you an actual area. If you ever hear somebody talk about the area under the curve, this is what they mean. It's asking you to find the area between the limits of 2 and 0 given this graph function right here. So with that out of the way, let's apply this same formula as we did last time and see what we get. So we know that the variable, or the power actually of the variable, is going to be 1. So that is what n is going to be equal to. So we're going to have 1 over 1 plus 1 times x raised to the x, or raised to the x raised to the 1 plus 1, my bad. You can tell I'm kind of tired, but hey, I like doing this kind of stuff, so it all balances out, right? Okay, so we also have this 2 over here. It's important to note that. I forgot to mention that here. So what we have here is, if we clean up this parenthesis, it's going to give us 1/2 times x squared, and we also have to multiply that by 2. Now what you can do here is that these 2's are actually going to cancel out, and we are going to be given x squared. Now, if this was a indefinite integral, we would say it would be x squared plus c, but because we have these new concepts, we actually have to plug these numbers in and subtract their differences. So what I'm going to do here, I'm going to draw this little line right here, and I'm going to say x is equal to 2, and x is equal to 0 in this case. So here's what I'm going to do. After I integrate it like normal, I'm going to plug 2 and 0 into this equation. So instead of x squared, this is going to be 2 squared. So I figured that part out, and now I'm going to subtract it, because if you remember from the equation earlier, this is f of b, which we know is 2, and then we have f of a, which right here is going to be 0. So that is going to be 0 squared. So now we can evaluate this. 2 times 2, or 2 squared, is going to be 4, and then anything that is multiplied by 0 is going to give us 0 in this case. So 4 minus 0 is going to be 4, and therefore we have evaluated it. So that is one example. Now let me go to the second example here. So we are asked to evaluate the integral between the boundaries of 3 and 1 times 3x squared dx. Well, let's apply the same concept that we did earlier. So what I'm going to do is I'm going to bring this 3 outside here. And we know that the power of this exponent is going to be 2, which is going to be the n power. So it's going to be 1 over 2 plus 1 in this case. And then it's going to be times x raised to the 2 plus 1. All right. So now I'm going to clean up whatever is in this parenthesis here. And it's going to be 1/3 x raised to the 2 plus 1, which is going to give us 3 in this case. So now I'm going to cancel out these 3's, and now we are just left with x cubed right here. So now we're going to apply the exact same concept we did for number 1, and that is we are going to evaluate both of these limits. So I'm going to do x equals 3 on the top, and then x equals 1 on the bottom. Okay, so now we're going to apply this. So we're going to plug in the 3 first into this x cubed. So that's going to be 3 cubed minus 1 in this case, and we are also going to cube that. Now 3 times 3 times 3, well 3 times 3 is 9. Multiply that by another 3, you get 27. And then anything, when you take 1 and raise it to any power, it's just going to give you 1 every time. So 27 minus 1, the area in this case is going to be 26. So we have completed that one. And now let's move on to this last example here. We are asked to evaluate the integral between the boundaries of 4 and 0 of 5 dx. Now, if you remember from the last video that I posted with the introduction to integration, whenever you are asked to evaluate a constant, in this case, you are only supposed to add an x to it, because unlike when you take a derivative of a constant which gives you 0, you're going to be taking the antiderivative, which means you are going to be adding a variable to that. So what you could do is you could add an x raised to the 0 here, and you could label n equals 0 in this case, and you could evaluate this here. So 1 over 0 plus 1, and then we have x raised to the 0 plus 1. Now, this is just for beginners. Once you start beginning to integrate, I suggest that you use this kind of a concept right here, but it'll get to a point where you're just like, oh, I can just do a 5x here. But for those of you who are beginners watching this video, this is a great starting right here. So x raised to the 1. Well, we know that this is just going to be technically imaginative, so we have 5x. And now, because we have integrated the function like normal, we are going to evaluate these two limits right here. So that's going to be x equals 4 and x equals 0. So let's plug in this 4, and then let's plug in this 0 here. So we have 5 times 4, so we completed that first half. And now let's plug in this 0 here. That's going to give us 5 times 0. Well, we know that anything multiplied by 0 is going to give us a 0. So I'm going to bring that down here. And 5 times 4 we know is going to give us 20. So 20 minus 0 is going to give us a 20. So therefore, we have evaluated this integral and we have solved for it. So that is pretty much all of the examples that we are going to go over. Like I said, this is an introduction to definite integrals. This is kind of like the part 2 of my last video that I uploaded. Feel free to check that out. But with that out of the way, I hope you enjoyed it, and I shall see you soon.